Listen here. Now we are going to learn the new concept called a law of conservation of energy. Conservation, the meaning of conservation is no change. That is the meaning of the conservation. Before and after, is it clear? Before some occurrence and after some occurrence, is it clear? There should not be any change in the energy. That is called as conservation. If there is no change before certain time and after certain time, by that time we have to use a term called conservation. Look at the statement given here. What is given in the statement of law of conservation of energy? Look at that. Energy can neither be created nor be destroyed. The meaning is energy cannot be created. Energy is not created by anyone. It shows that the meaning is energy is already present in the universe. Energy is available in various forms in the universe. Look at the second part of the sentence. Energy can neither be created nor be destroyed. It shows that you are not able to destroy the energy. We human beings or by somebody else, we can't destroy the energy. It shows that you are able to transform the energy from one form to another form. You are the agent. You are capable of transforming one form of energy into another form. That is the only possible thing. Look at the second statement. One form of energy can be transformed into any other form. For example, if you have muscular energy, with the help of muscular energy, you are able to perform work. Your muscular energy can be converted into mechanical energy. Okay, to ride the cycle, what is required? You should have muscular energy. With the help of muscular energy, you are able to transform the energy into mechanical energy. In the case of fan, you are supplying electricity. Electricity can be converted into mechanical energy. In the case of calling bell, if you supply electricity, that electric energy can be converted into sound energy. Like that, one form of energy can be transformed into any other form. So these two statements are very important. Okay, this is universally accepted one. Are you clear? So we are going to learn the meaning of conservation of energy by using this following illustration. Mainly, we are going to concentrate on the mechanical energy. Make a note. You know what is mechanical energy? Mechanical energy is energy required to displace the bodies. To move the bodies, which kind of energy is required? Mechanical energy is required. This mechanical energy, they can be broadly classified into potential energy and kinetic energy. Already the definition, expressions, everything was explained basically in a very detailed manner in the previous topics. So mechanical energy can be classified into potential and kinetic energy. To calculate the potential energy of the body, we are using the formula mgh in the case of free falling bodies. If any body is lifted up to certain height, the potential energy at various positions can be calculated by using the formula mgh. Whenever any body is in motion, that body it possesses the kinetic energy by virtue of its motion. Therefore, velocity is very important. Okay, with the help of velocity and mass, kinetic energy of the moving body can be calculated. To get the total energy, what we have to do? Total energy of the system that can be calculated by summing up the kinetic energy and potential energy. If both are added, you will get the total energy. So as per law of conservation of energy, the total energy of the system is constant. Are you clear? This is always constant. Make a note. Always the total energy of the system is constant. It won't vary. Are you clear? So if you add both, you will get the number. No, that number, that value, it won't change. I will explain this concept, that law of conservation of energy, clear, with the help of the illustration. That we are going to prove that the total energy at all positions, it should be proved as constant. Here let us imagine a mass 1 kg, and here the body is raised, lifted up to certain height. The height is 10 meters. It is located, it is raised at a height of 10 meter from the ground level. H value is 10 meter. G can be roughly taken as 10 meter per second square instead of 9.8. For mathematical convenience, so clear, I have used G as 10 meter per second square. We know the value of M, G and H. Okay, here the object is raised up to certain height, no, because of its change in position. Certainly this body, it is also at rest at position A. The body is at rest, it is not in motion. Because of the change in position, the body should have which kind of energy? The body should have potential energy. How will you calculate the potential energy here? What is the formula? Potential energy can be calculated by mgh, that is the formula. M value is 1 kg, g value is 10, height is 10 meter. Therefore, the total potential energy, the potential energy value is how much? 100 joule. So, at A, that is at a height of 10 meter, the body is having exactly 100 joule amount of potential energy. Are you clear? Now, my question is whether exactly this body is possessing kinetic energy or not. It should not have kinetic energy because the velocity at A is 0. If the velocity is 0 means for the body at rest, is clear, the kinetic energy is clear, that can be calculated by the formula half mv square. Since the body is at rest at A, is clear, now we can substitute velocity as 0, therefore kinetic energy is 0. Are you clear? Now how to calculate the total energy of the body at A? To calculate the total energy of the body at A, this both of them, both the two must be added. Add both, you will get 100 joule. Are you clear? The total energy at A is how much? 100 joule. Are you clear? Now I am going to calculate the potential energy and kinetic energy at various positions. Now the body, it has come to a new position B, that is at a height of 9 meters. Are you clear? Can we calculate the potential energy here? Are you clear? That could be calculated very easily. How will you calculate? Now the potential energy at B position is 1 kg 10 into 9. So 90 joule is the potential energy value. Are you clear? So at B, what is the potential energy value? 90 joule. What you have observed from the observation? Here previously the potential energy was more, 100 joule. When the position is clear, slowly it is decreased. When the height is decreased, the potential energy value also decreases. And in the meantime, the body starts moving, the object starts moving. So it possesses some velocity. When the object possesses some velocity, definitely it should have kinetic energy. So how will you calculate the kinetic energy? The kinetic energy value, clear, must be 10 joule. How can I say? Because if both are added, you should get 100 joule. Are you clear? Look at the observation. Potential energy decreases, kinetic energy increases. Again, if you add both, you are able to get the clear value of total energy. Look at the total energy remains constant. Can we calculate the kinetic energy? The clear kinetic energy is 10 joule means what should be the velocity? That knowledge is also essential. The kinetic energy is equal to half mv square. Are you clear? Kinetic energy is known here, 10 joule. Are you clear? Half mv square. V square is equal to 2 into 10 divided by m can be written 2 into 10 divided by mass is how much? 1 kg. Are you clear? So 10 joule amount of kinetic energy is there for the free falling body. Mass is 1 kg. We are going to calculate the velocity. How will you calculate the velocity? Cross multiply 2 into 10 divided by m can be substituted. Therefore 20 is the value. So v square is equal to 20. So what should be the value of v? That 20 must be clear, taken as in the form of square root. That square root of 20, that one gives you the velocity that can be written in terms of meter per second. So this is a method by which we are able to calculate the velocity. So our aim is not to calculate the velocity, just I would like to represent clear how to calculate the velocity. Now look at that. As per the statement, is it clear? Look at the first statement. What is told here? Energy can neither be created nor be destroyed. Energy is not destroyed here. Wherever you measure the total energy remains constant. But one form of energy is converted into another form. Look at that. potential energy. Previously it was in the form of potential energy. That potential energy is slowly converted into kinetic energy. Potential energy value decreases, kinetic energy value increases. Let's come to the point C. Are you clear? How will you calculate the potential energy? P is equal to same formula mgh. Mass value is 1 and g value is 10. Height is 8 meters from the ground level. Always h must be measured right from the ground level. So what is the value? 8 joule is the potential energy value. Substitute here 80 joule. So definitely, obviously, the value of kinetic energy must be 20 joule, isn't it? Now what happens? Again you add both, you are getting 100 joule. So like that, if you calculate the potential energy and kinetic energy value in the subsequent steps in various positions at D, at E, at F, at G, at H, at I, at J, and finally L. L is the lowest level, ground level. So if you calculate what happens in the next level, the potential energy value will be 70 joule and kinetic energy value will be 30 joule. If both are added, you will be getting 100 joule. So at all position, total energy remains constant, but the nature of energy, the form of energy, it changes. Look at that, potential energy decreases, kinetic energy increases. Let's write the next one, 60 joule here in this position at E. The kinetic energy value increases to 40 joule. Again total energy remains constant, 50 joule, 50 joule. The total energy is 100 joule. Look at that. Exactly at F, it is partially kinetic and partially potential. So clear, half of the value is kinetic, half of the value is kinetic, half of the value is potential. That's why we have to call it as partially kinetic and partially potential. But again what happens? The total energy remains same. Are you clear? So when it is descending down, the velocity it increases. Initially the velocity may be v1. In the C position, velocity is increased to v2. When it is descending down to D position, velocity is increased to v3. Each and every moment velocity increases. Are you clear? When velocity increases, kinetic energy also increases. Make a note. Why kinetic energy increases? Because of the gravitational pull, velocity v1, v2, v3, if you compare, v3 is greater than v1 and v2. So when it is descending down, it strikes the ground with the maximum velocity. Are you clear? Therefore, while striking the ground, the body will possess the kinetic energy alone. When it strikes the ground, the body it won't have any potential energy. Are you clear? Initially, the body will have potential energy. Are you clear? When it strikes the ground, all potential energy will be converted into kinetic energy. So potential energy is converted into kinetic energy, but total energy of the system remains same. Let's take the position G now. 40 joule, 60 joule, 100 joule. Again total energy remains constant. And then 30 joule, 70 joule. And then see, look at that. So slowly the value of Ke increases. Again if you add, you will get 100 joule. So everywhere, clear, all the values of total energy remains constant. Are you clear? Wherever you measure, okay, the total energy of the system remains constant. And then 20 joule, and then 80 joule, 100 joule. Again the total energy remains constant at I position. Are you clear? 10 joule, 90 joule, 100 joule. Total energy remains constant. Look at the final interesting thing. Here, well, when it strikes the ground at the lowermost position L, what is the height of the ball? Height of the ball from the ground level. The height of the ball, position of the ball from the ground level is 0. It strikes the ground now, therefore H is equal to 0. Are you clear? Substitute in the formula. Mass is there, G value is 10 and height is 0. Therefore potential energy value is 0 joule. Therefore we can write it as 0 joule. Initially it was 100 joule, now it is 0 joule. So the energy is fully in the form of kinetic. Here the energy, total energy is fully in the form of potential. Are you clear? Total energy is purely in the form of potential. Total energy is purely in the form of kinetic. Add again, what you will get? 100 joule. Are you clear? So add again you are getting 100 joule means everywhere clear the total energy remains constant. So here from this observation it is confirmed that one form of energy is converted into another form. Kinetic potential energy is converted into kinetic energy. Potential energy is converted into kinetic energy. Are you clear? At A, the total energy is fully in the form of potential energy. Are you clear? At lowermost point, the total energy is in the form of kinetic energy. Are you clear? Make a note. Here, the kinetic energy contribution is 0. Here, potential energy contribution is 0. So, total energy is fully in the form of kinetic. In the in-between stages, the total energy is partially potential energy and partially kinetic energy. But the total energy remains same. The total energy of the system remains same. So this is the thing which we have to learn clear in the law of conservation of energy. The energy may be either in the form of potential or in the form of kinetic or in the form of partially potential or in the form of partially kinetic energy. But the total energy of the system, it remains constant. Are you clear? Very important one. See, I will say one example, simple example. Let us imagine a sand surface. You just take a shot put or any heavy object, heavy ball, metal ball. You just drop it, what will happen? After dropping, when it strikes the ground, that sand particle, they will be clear, thrown in different direction. Are you clear? So there will be a great impact that is created on the ground. Initially the metal ball will have a tremendous amount of potential energy. Are you clear? So that is the total energy of the system. After striking this metal ball, that one will move with greater velocity. The entire energy, potential energy will be converted into kinetic energy. That kinetic energy, clear, that potential energy is converted into kinetic energy, that kinetic energy that could be visualized by seeing the splash of that sand particles. Are you clear? That one will be thrown in different direction. Are you clear? You can see the splash of, is it clear, or the movement of the burst of the sand particle in various directions. Are you clear? So that impact that can be seen, that could be visualized, is clear, in the simple demonstration. Are you clear? Very interesting one, simple one. So the statement is very important. Okay, thank you.